Oh, hi there. Today we're going to have a look at a quick way to add reflections that are calculated based on the geometry surrounding the player. We will just add a component to the character, and then we will use line trace results from that component to inform a tap delay which is placed on a submix, which can then be mixed with the rest of the game. So we're starting on the player. We have placed this audio tracer component, and this one, if I go to edit it, inherits from the SweejTech tracer component, which is a way to do asynchronous line traces to, like I said, get information about the geometry surrounding the player. So we have these settings, total trace results and traces per frame, and this just round robins between these asynchronous traces. It will first do a lap of horizontal traces, and then from each horizontal result it will do a vertical trace upwards. And based on that it will calculate the value we call indoorness. So again, I've just drag and dropped this component onto the character. From here I've created a simple blueprint graph which updates the indoorness, and what this one does is that it just takes the indoorness value which is calculated on SweejTech tracer component, and this is essentially just checking how many of the vertical line traces hit a target. If the vertical trace didn't have a hit, then it won't add to indoorness. And the only thing we're doing in this blueprint is that just we're adding some interpolation so that it's a softer transition when going between areas. Then we just get the owner jaw based on the actor. We get the rotation and we store that, because while the audio ambience tracer component can be set to follow the owner rotation, that will mean that you get different results if you rotate on the spot, and we don't want that. If we go into the calculate reflections function, we can just quickly have a look at this. It's a bit of logic here, but it isn't as crazy as it looks. Some of it is just setup. So here, for example, we define which submix effect we're using. So again, we're using a tap delay. This one is set to have 8 taps. I'm in a 5-1 speaker setup right now, so it's 2 per speaker essentially when I'm sending to the quads, and that helps ease the transitions a bit. It doesn't become as clear that it's a delay coming from that speaker, so it's a bit smoother than that. But the important thing here is the panning. We don't want to send to a channel, we want to use panning, and that means that the tap delay can end up between speakers, which makes it nice when you're rotating. Then we loop through as many results as we want. So this will be 8 channels. Store the index. From here we have also set a list of angles. So again, we're accessing the tracer component. This blueprint is inheriting from the AM tracer component, so it's getting itself and then getting the angle, and from that we get a Sweej trace result which looks like this. So we have a horizontal trace and a vertical trace for each entry. So we have, if you remember, we had 16 trace results is what we're storing, and those are being continuously updated. Then, based on the owner jaw and the horizontal angle, we set the ray angle. And these are local variables that we're storing. So this will happen, these settings will be updated 8 times per frame, based on the fact that we have chosen to do a for loop of 8 items. Then we set the distance and we get the angle of the hit. So basically we're looking, we also get the angle of the hit where we're comparing normal to the direction of the trace. And based on the angle and the distance, we are calculating the delay time. And based on the hit angle and the distance and the delay time, we are calculating the gain to set. I guess that could be simplified. There is some double whammying here, but this is what we're doing now. It's gonna be alright. I might just skip this in the video. So once we have these properties set, we just need to set it on the tap delay. So again, we're having this local variable which is just pointing us to the correct submix effect. We have the tap IDs which we set from the beginning here. So we just stored the tap IDs of the effect tap delay preset. And that's the way you access the effect settings. So from here, we actually override all of the settings in the effect. So this, whatever was set here before, doesn't matter because we're setting it here. So we're setting the panning mode, and we're setting the delay length, which I'm actually calling delay time. We're setting the gain, the output channel. This is only used if we are using the channel mode, center channel, but we're not. We're panning, and therefore we're using the pan in degrees. That is the entire setup. So if we're gonna try this in the game now, I've boosted the tap delay so that it's a bit more audible than I would have mixed it in game, just to make it clearer what's happening. Alright, as you can see in the top left corner, I'm printing some debug there, and that will show you the data while I'm running around. So if I just run here, should be able to hear that I'm having reflections on my left hand side when the wall's on my left, and on my right hand side when the wall's on my right. So just walking around the city here, you can hear a bit of what it's doing. So there you have it. You could do this with any type of trace results. You could build your own in blueprints. The risk there is that the blueprint version is synchronous, and engineers interested in performance won't be super happy. The upside with this one is that it's doing it asynchronously, and those engineers will be less upset. But at the end of the day, it's about getting line trace results from the geometry surrounding the player, calculating some gains and delay times based on that, and then just setting them on the submix with a submix effect of tap delay. And then I've also applied some low pass and high pass filter here to remove boominess and the treble. So yeah, that's it. Thanks for watching.